as being the hardest question on here. So first off, what does this mean? What is this d squared y dx squared? What is that asking for? Okay, so you got to know that. That's not something I can help you with on the test. The first derivative shouldn't be too bad because it's just something to the third power. So power rule, bring the power down, lower the power by 1, and what else? And chain rule, always chain rule. So to make this look a little bit nicer, 3 times 6 times x times this stuff squared. So are you okay with that with the first derivative?
Yeah.
So that's not too bad, not too messy. But this one's second derivative. So now we got to take the derivative of the derivative. And this is where it gets a little messy. Now, to be honest, you've got two choices here. If you guys want to avoid product rule, because this is x times something, so you could do product rule. You could do a bunch of algebra first. You could square this and FOIL it, and then distribute 18x to everything, and you're going to have like 3 terms, I think, and then you could just do power rule 3 times. Now, based on how the answers are written, I don't know if it would be easy to match up those choices. So I'm going to go with product rule, but just so you guys know, like you could do some algebra legwork there first before trying to do calculus. Okay, so this 18 out front is just going to make it 18 times bigger. So I'm going to put it out front and put in parentheses, and then I don't have to think about it anymore. I don't have to worry about losing it. And so product rule says take the derivative of the first times the second left alone.
Or I guess the question I had is, why didn't you do it at the derivative of 18x? Why did you take 18 out of it?
Well, it's just going to be 18 times bigger. Like, what's the derivative of 2x?
2.
It's 2 bigger than the derivative of x, right?
Okay.
So I just pulled it out front, because if you don't, then you're going to have more 18s in here, which is fine. It's just a little harder to keep up with.
Yeah.
So that's just a preference thing. Okay, and then switch it around. So now leave x alone. Take the derivative of this. So this would be like power rule. Bring the power down. Lower the power by 1. And once again, don't forget chain rule. Chain rule is one of the hardest things to see early in the year. So multiplying by 1 doesn't do anything. 2 times 6 times x gets me to there. So I just tried to combine some like terms and stuff. You okay to that point?
Yeah.
Okay, and then to be honest, the next to last step here is not something I would think to do, except that I'm looking at the answer choices, and notice a lot of the answer choices have this 3x squared minus 1 in there. So if I just start like multiplying this stuff together, I'm going to get a million terms, and I'm not going to know which one's the same as this. So based on that hint, what I notice about this term and this term is they have a GCF, they have a 3x squared minus 1 in common. So I would factor it out. And then that would leave behind a 3x squared minus 1, because there was 2 of them. So if I pull out 1, there's still 1 left behind. And then over here, this would be a 12x squared. You okay with the GCF part?
Yeah.
And then the last thing, if you combine 3x squared with 12x squared, you get, which would look like choice A. So just taking the second derivative makes the question longer, makes it a little bit harder to keep up with our work. But the individual pieces are all important. The power rule and chain rule, certainly going to be on your test. Product rule, certainly going to be on your test. sometimes you've got to do chain rule more than once in a question. It's not like once you do chain rule once, you think you're off the hook for the question. It could show up multiple times. Showed up here within the first derivative, and showed up here again during the second derivative. Yeah.
Could you go over again how you got the GCF out of that 12x squared to the derivative?
Sure. So really, I've got two terms here. Terms are things that are being added or subtracted. So I can just see that they both have a 3x squared minus 1. So since they both have that in common, I can pull that out front.
Okay.
And when you're factoring out a GCF, you're just undistributing. So I need this times this to give me that. So it has one of them, but it needs another one. So that's where that comes from. And then this distributed to this needs to give me this term. So it needs the 12x squared.
Got it, okay.